All right, we are in chapter 5-7. This one's called distance on the coordinate plane. On this particular example, what we want to do is graph these 2 points, and we want to find the distance between the 2 points. All right, so what we do first is graph 3, 0. Keep in mind that the 3 is the x coordinate and the 0 is the y coordinate. So over here, this will go 1, 2, 3. So that will be 3 on the x. Let me put a dot right here. That's 3, 0. Okay, that means 3 to the right and don't go up or down. That's why the y is 0. So we're not going to move off of the x axis. And then it says 7, -5. So this will be 1, 2, 3, 4, 5, 6, 7, and then down 5. Okay, so if I go down 5, I'm going to be right here. All right, so down 5. So right over here, let me just put -5 right here. So we know 1, 2, 3, 4, 5, -5, right? So we have these 2 points, and I want to find the distance between them. I'm going to find the distance between them. So when we're on the coordinate plane, that's very easy to do. So watch what we do. First of all, I want to connect a line between the two. So that's the line that's connecting those 2 points. I need to find out how long that line is. As you can see, because the line is diagonal, I can't clearly say how many boxes it goes across, because diagonally we can't count it that way. But we can do something else. What I want you to be able to do is, because we're on a coordinate grid with all these straight lines everywhere, I want us to create a triangle. I want us to create a triangle like this. Should go straight down from here and then straight across this way. All right. Now I have a triangle. Why is that critically important? Because with this triangle, okay, let me get that line out of there. With this triangle, I can now create my right angle. So let me do that. Let me get my regular line here. I want you to see that there's a right angle right here. Okay. The opposite of that right angle, okay, is my C. Can you see what I'm drawing here? I got a right triangle, and I want to try to use the Pythagorean theorem to find the distance of the hypotenuse. That's what I want to do. So this is side A, and this is side B, and that is the hypotenuse, which is C. All right. So, okay, let me label this also X, Y. Don't forget that. All right. So now, what is the distance of side A? Well, from here going down, what I want to do is this. Let me do this. I want to make sure that we can see it. Let me use black here. Let me do that. From here, I want to count 1, 2, 3, 4, 5. That's 5. And then let me go this way. 1, 2, 3, 4. That's 4. All right. So based upon that, let's write our formula over here. We know the formula for the Pythagorean theorem is a squared plus b squared equals c squared. And what I want to do, I want to take the distance we just found for side A, plug it in right here. So that's 5 squared plus the distance that we found for B, 4 squared equals c squared, our hypotenuse. So now we know that that's going to be 25, 5 squared is 25, plus 16, 4 squared is 16, and that equals c squared. When we add these two together, we get 41 equals c squared. What do I do now? You already know how to get rid of the square. We have to square root, the opposite, right? So the square root gets rid of the square, and I'm left with c. And the square root of 41 is positive and negative 6.4. By the way, this is approximately. So let me change my symbol over here to approximately 6.4. Now, understand that since we're dealing with distance, we have to rewrite this to be a positive 6.4 only, and it's still approximately. We round it to the 10th place. It cannot be negative. Distance cannot be negative. All right. This means if this is 5 units and this is 4 units, I'm using the word units because it could be inches or miles. And if I don't designate it, if I don't let you know what it is, then I want you to use the term units. If that's 5 units and that's 4 units, this hypotenuse must be greater than those numbers. I already know my answer is bigger than 5. Hypotenuse is always the longest side. The hypotenuse is the longest side. So that means that this side must be approximately 6.4. All righty? Very good. All right, let's look at another question. All right, here's another problem. The direction says on a map, each unit represents 45 miles. All right, so imagine a map that you're looking at, and each unit on that map is actually 45 actual miles. West Point, New York is located at 1.5, 2. That's the order pair where that dot is. And Annapolis, Maryland is located at negative 1.5, negative 1.5. Where that dot is where that place is located. What's the distance between these 2 points? What is the approximate distance between West Point and Annapolis? All right. Now, we don't actually have to see the map. You will see the map in your book on page 433, but we can actually do this without looking at the actual map because everything we need is already in the problem. First thing I want you to do is set up your points. They gave us 2 points. Let's write down New York's point. It says New York is located at 1.5, 2. And Maryland is located at negative 1.5, negative 1.5. Now, wherever this is on the map, I just need the distance between the two. All right. So first thing I want us to do is label our points. Label them. This is X and this is Y. This is X and this is Y. Now I want you to go back and continue the labeling, but I want you to add a number. This is X1, Y1. The first group of numbers are ones. Those are not exponents. It's only a designation. It's like a subscript number is called. So X1, Y1, and this is X2, Y2. So if I talk about the first or the second X, you know which one I'm talking about. The first or the second Y, you know which one I'm referring to. They're just designation numbers, all right? Now, what we want to do is take these numbers and plug them into our formula, which is up here, all right? This is called the distance formula. This is what we use when we don't have a coordinate grid to put the points on to create the triangle that we did last time to give us, the right triangle. We can actually use a formula besides drawing it on a coordinate grid. So the formula goes like this. Distance equals the square root of x2 minus x1, square that, plus y2 minus y1, and square that. Let's extend this line. You're going to work all that out, and then we're going to get the square root of it all. All right? I want you to see something here. This is actually represents x2 minus x1 actually represents A, and y2 minus y1 represents B. So I need you to think of this as the Pythagorean theorem, written a different way. This really says A squared plus B squared equals C squared. Remember what we do to get the C alone? Square root it. That's why that square root symbol is above it. So you'll see it when we work this all the way out. Let's keep going. So what I want us to do here to find the distance, D is for distance, is to plug in our numbers. X2 is right here. All right, so what we want to do, let's go ahead and draw that again. All right, so X2 is negative 1.5 minus X1, which is 1.5. We're going to square that, plus y2, which is here, negative 1.5 minus y1, which is 2. Square that. All right. All right, now that we got our numbers plugged in, let's go ahead and work this out. This is going to be, we got to keep writing our square root symbol until we get the square root. This is a requirement. Please write this square root symbol each time. All right. All right, here we're going to have, what is negative 1.5 minus 1.5? You should know that that is going to be a negative 3 to the second power plus, what is negative 1.5 minus 2? That is going to be a negative 3.5. Don't forget to square it, second power. All right. Let's go back. Let's go on this side here. I need some more room over here. So I'll write it over here. D equals. Give me that long square root thing there. All right. So now what do we have? What is negative 3 squared? From here, I'm taking it from down here, right? This is going to be 9 plus, remember, negative times negative is positive. All right. Negative 3.5 here to the second power is 12.25. All right. Now, what do we do here? We add those two numbers together and we get 21.25. That's 9 plus 12.25. All right. That is 21.25. All right. Now, the last step here, the distance. I need a squiggly line here, I call it, because I'm getting the square root of this, and it will be an approximate number. It's going to be approximately plus and minus 4.6. And you already know that my final answer on this part of it will be approximately a positive 4.6. Now, you would think that you would be done, but if you write that answer as your final answer, unfortunately, you are not complete, because look at the first sentence in the question again. Let's look at it. It says, on a map, each unit represents 45 miles, right? This is the most important part. Why is that? Because this answer down here represents the units. That is 4.6 units. All right. So what we have to do is, I'm going to write it way up here. I'm going to take the 4.6. Each unit is actually 45 miles. So I'm going to multiply 4.6 times 45. All right. And that will give me approximately 207 miles. That's the distance between these 2 points. If each unit on the map is 45 miles, I need to take each unit and multiply by 45 to get the total distance in miles on the map. So in this case, the distance between New York and Maryland is approximately 207 miles. All right. Very good.